Combustion and flame. Lesson preview. Combustion, combustible and non-combustible substances. Conditions necessary for combustion. Controlling fire. Use of fire extinguisher. Types of combustion. Flame. Zones of a candle flame. Fuel. Fuel efficiency. Hazards of burning fuels. Fuel is a substance that burns in air to produce energy in the form of heat and light. We use different kinds of fuels. At home, for running automobiles and in industries. We use fuels like cow dung, kerosene, and LPG at homes, CNG, diesel, and petrol for running automobiles, and coal to produce electricity in thermal power plants. You must have seen that some substances like candle burn with a flame, whereas others like coal do not. Let us now study the process of burning in detail. Combustion. Combustion is a chemical process in which a substance reacts with oxygen and produces heat and light. When you heat a piece of charcoal by bringing it near a Bunsen burner, it burns in air producing carbon dioxide, heat, and light. Burning of charcoal. Burning of magnesium ribbon. Substances can be classified as combustible or non-combustible depending on whether they burn or not. Combustible substances. Substances which can burn in air or oxygen to produce heat and light are called combustible substances. A combustible substance can be solid, liquid or gas. Charcoal, magnesium ribbon, kerosene, diesel, petrol, LPG, wax, paper, cloth, wood, etc. are some examples of combustible substances. Non-combustible substances. Substances which do not burn in air or oxygen are called non-combustible substances. Some examples are sand, water, glass, cement, etc. Activity: collect a small sample of the following materials: matchstick, paper, straw, cloth, sand, cement, and aluminium foil. Hold each one of them turn by turn with a pair of tongs, and heat them in a candle flame. Do this under the supervision of an adult. Note down your observations. Table. Serial number. Substance. Burns. 1. Matchstick. 2. Paper. 3. Straw. 4. Sand. 5. Cement. 6. Cloth. 7. Aluminium foil. Matchstick, paper, straw, and cloth are combustible substances, whereas sand, cement, and aluminium foil are non-combustible substances. Products of combustion. Fuels are mostly made up of hydrocarbons, i.e. substances made of hydrogen and carbon only. When a hydrocarbon burns completely, the products formed are carbon dioxide and water. Heat and light energy are released. Complete combustion occurs when a fuel burns with sufficient amount of oxygen to support the burning process. For example, when methane burns in ample supply of oxygen, carbon dioxide and water are formed, and energy, heat plus light, is evolved. CH4 methane plus 2O2 oxygen, CO2 carbon dioxide plus 2H2O water plus energy. Conversely, if limited oxygen supply is available, incomplete combustion occurs. The resulting products in this case are carbon monoxide, water, and energy. 2CH4 methane plus 3O2 oxygen, 2CO carbon monoxide plus 4H2O water plus energy. Conditions necessary for combustion. Activity. To test the conditions needed for combustion. Note: be careful while lighting a candle. Fix a lighted candle on a table and make arrangements as shown in Fig. A. Cover it with a chimney. Rest it on a few bricks so that air can enter the chimney. Observe the flame. Now remove the bricks, so that the chimney may rest on the table, leaving no space for air to enter from below. Observe the flame. Now cover the top of the chimney with a glass plate. Again watch the flame. Note down your observations. Candle in. A. Candle burns freely as air enters the chimney from below. Candle in. B. Flame flickers and produces smoke as no air enters the chimney from below. Candle in. C. Flame extinguishes as no air is available. This activity clearly shows that air is necessary for combustion. Activity. Take some spirit in a glass bowl. Place a cotton wick in it, and ignite. It will burn. Now cover the bowl with a lid. Does the wick stop burning after some time? Can you guess the reason? Carry out this activity under the supervision of an adult. Paper and wood do not burn by themselves. You need to burn paper with a burning matchstick. The matchstick will not burn wood. You have to use paper or kerosene oil to start fire in wood or coal. This shows that different substances catch fire at different temperatures. A substance starts burning only after it has attained a certain minimum temperature. The lowest temperature at which a substance catches fire is called its ignition temperature. Different substances have different ignition temperatures. A matchstick does not catch fire on its own. It immediately catches fire when rubbed against a rough surface. Various substances like coal, wood, LPG, and kerosene do not catch fire on their own. They need a spark or a burning matchstick to burn them. Substances like alcohol, petrol, LPG, and synthetic fibers catch fire easily. This is because these substances have low ignition temperatures. They are said to be inflammable substances. Activity. To show that a substance does not catch fire at a temperature below its ignition temperature, take 2 paper cups. In case you do not have paper cups, fold a sheet of paper to form cups. Pour about 50 milliliters of water in one of the cups. Hold the 2 cups separately over 2 candle flames as shown in the diagram. What do you observe? The empty paper cup catches fire and starts burning. The cup containing water does not catch fire. The water in it becomes hot. You can even boil water in it, if heating is continued. Note: do this activity under the strict supervision of an adult. Paper cups. Water. The candle flame raises the temperature of the empty cup above ignition temperature, hence it catches fire. The heat supplied to the second paper cup gets transferred to water by conduction. As a result, the paper cup does not reach its ignition temperature. This is the reason why it does not burn. Thus, we see that the necessary conditions for combustion are: 1. Presence of a combustible substance. 2. Adequate supply of a supporter of combustion, for example oxygen. 3. Attainment of ignition temperature. Substances with very low ignition temperatures are called inflammable substances, which can catch fire very easily. Examples are petrol, kerosene, LPG, and alcohol. These substances have to be stored very carefully as even a little spark can ignite them and cause a major fire. Complete combustion. When the supply of oxygen is sufficient, the substance will burn completely. Complete combustion is less polluting. Incomplete combustion. When the supply of oxygen is inadequate, the substance does not burn completely and the combustion is said to be incomplete. This combustion results in the formation of carbon monoxide, soot, water, heat, and light. Thus, we see that a number of pollutants are produced. When the supply of oxygen is inadequate, the substance does not burn completely and the combustion is said to be incomplete. This combustion results in the formation of carbon monoxide, soot, water, heat, and light. Thus, we see that a number of pollutants are produced. Combustion is an irreversible chemical reaction. All combustible reactions produce heat. Most of them also produce light. Carbon dioxide and water are also produced in the process. Controlling fire. As we have seen that three conditions are necessary for a fire. Fire can be extinguished if any one of the three conditions cease to exist. By cutting off supply of oxygen. By removing the combustible substance. By lowering the temperature below its ignition point. Fire is extinguished by the following methods. When water is sprayed over a burning substance, it brings its temperature down below the ignition point and the fire is put out. Water vapor formed due to the heat of the fire cuts off the supply of oxygen. The fire is extinguished. Do not use water over burning kerosene, petrol or diesel. This is because oil is lighter than water. It will form a light layer on water. The fuel will continue to spread to other areas, as the oil will flow along with water. Water should also not be used in electrical fires. Water is a conductor of electricity and can cause electrocution. Sand or a fire extinguisher is preferred in such situations. When clothes of a person catch fire, his body is covered with blanket to stop the supply of air, oxygen. In the absence of air, combustion will not occur. Hence, the fire will be extinguished. Use of fire extinguisher. Carbon dioxide, CO2, is the best extinguisher for fires involving electrical equipment and inflammable materials like petrol. Carbon dioxide, being heavier than oxygen, envelops the fire and cuts off the supply of oxygen. Fire thus gets extinguished in the absence of the supporter of combustion. Generally, carbon dioxide also does not harm the electrical appliances. CO2 can be stored at high pressure as a liquid in cylinders just as LPG is stored in cylinders. When CO2 is released from the cylinders, it expands a lot and envelops the fire besides bringing down the temperature of the fire. This is the reason why CO2 is widely used as a fire extinguisher. Another type of extinguisher is the soda acid fire extinguisher. In this type of fire extinguisher, sodium hydrogen carbonate and sulfuric acid are present in two compartments in the fire extinguisher. When the extinguisher is used, the two come in contact with each other producing carbon dioxide. 2NaO3 sodium bicarbonate plus H2SO4 sulfuric acid, Na2SO4 sodium sulfate plus 2H2O water plus 2CO2 carbon dioxide. Some other types of fire extinguishers are: foam fire extinguishers are used to put out fires caused by solids or liquids. Dry powder fire extinguishers are effective in putting out fires caused by liquids and faulty electric wires. Types of combustion. There are three types of combustion: rapid combustion, spontaneous combustion, explosion. Rapid combustion. In this type of combustion, large amounts of heat and light are produced in a very short span of time. Examples are combustion of LPG, kerosene, petrol, etc. Spontaneous combustion. In this type of combustion, substances suddenly burst into flame on their own, without any apparent cause. Example: white phosphorus burns in air at room temperature producing heat and light. At times, spontaneous forest fires are caused due to the heat of the sun or due to lightning strike. This mainly occurs due to extreme heat of summer. Forest fires are very difficult to control. Many forest fires take place due to carelessness of human beings, like not extinguishing a campfire completely before leaving a forest after a visit. Spontaneous fires in coal mines can take place due to spontaneous combustion of coal dust. Explosion. In this type of combustion, heat, light and sound are produced accompanied by the liberation of a large amount of gas. Bursting of fireworks is an example of explosion. Explosions can also take place if pressure is applied on the cracker. Flame. Different flames burn with different colors. A matchstick burns with a yellow flame, whereas an LPG flame is blue in color. Magnesium ribbon burns with a dazzling white flame. Matchstick. LPG flame of a kitchen stove. Magnesium ribbon burning in air. Kerosene lamp has a yellow and smoky flame, but kerosene gives a blue and smokeless flame when burnt in a stove. Flame is a region where combustion takes place. The color of a flame depends upon the temperature, amount of available oxygen, and the nature of the combustible substance. Only solid and liquid fuels which vaporize on heating burn with a flame. Kerosene, liquid fuel, and wax, solid fuel, both vaporize during burning and form flames. Charcoal does not vaporize and hence does not burn with a flame. However, all gaseous combustible substances burn with a flame. Activity. To show wax vapors produce flame note, carry out this activity under the supervision of an adult. Fix a lighted candle on a table. Hold a glass tube with a pair of tongs, and bring one end of it into the dark zone of a well-lighted candle. Bring a lighted matchstick near the other end of the glass tube. What do you observe? It is seen that wax near the heated wick melts quickly. The molten wax rises through the wick and is vaporized during burning and forms a flame. This shows that when a candle is lit, it is the wax vapors that burn and produce flame, and not the liquid wax. Zones of a candle flame. A candle flame has 3 different colored zones, depending on the amount of oxygen available. Outermost non-luminous zone, blue. This is the hottest part of the flame. This zone emits very little light. In this zone, wax undergoes complete combustion because there is plenty of oxygen around it. Luminous zone or middle zone. This zone is bright, yellow and luminous. It is less hot than the outer zone. In this zone, there is incomplete combustion of wax vapors due to low supply of oxygen. Carbon particles are produced. This zone emits the greatest amount of light. The inner zone, this is the dark zone. It is the coolest part of flame. Since oxygen is not available in this zone, no combustion takes place here. The zone is dark and emits no light. Now you will understand why goldsmiths use the outermost part of the flame. They use a metallic blowpipe for melting gold and silver in the outermost zone of a flame. Outer zone of complete combustion, blue. Hottest part. Moderately hot. Middle zone of partial combustion. Least hot. Innermost zone of unburnt wax vapors, black. Fuel. In the previous chapter, we have studied what a fuel is. Now let us learn some qualities about a good fuel. Substances like wood, charcoal, petrol, kerosene, etc. that produce heat and light on burning are called fuel. Characteristics of a good fuel. It is easily available and cheap. It burns easily in air at a moderate rate. It produces a large amount of heat, high calorific value. It does not produce any poisonous and irritating fumes during burning. It is safe to store, transport and use. It leaves no ash on burning. Its ignition temperature is above room temperature, but otherwise low. Remember, there is no fuel which can be considered as an ideal fuel. However, natural gas best meets all these conditions. Types of fuel. Table. Solid fuel. Liquid fuel. Gaseous fuel. Coal. Kerosene. Natural gas. Coke. Petrol. LPG. Cow dung. Diesel. Coal gas. Wood. Biogas. Charcoal. Petroleum gas. Fuel efficiency. The amount of heat energy produced on complete combustion of 1 kilogram of fuel is called its calorific value. The standard unit of calorific value is kilojoule per kilogram, kilojoules/kg. The higher the calorific value of a fuel, the more heat it produces on burning. Calorific values of different fuels. Table. Calorific value, kilojoules/kg. Fuel. Calorific value, kilojoules/kg. Wood. 17,000 to 22,000. Methane. 55,000. Coal. 25,000 to 33,000. CNG. 50,000. Petrol. 45,000. LPG. 50,000. Kerosene. 45,000. Biogas. 35,000 to 40,000. Diesel. 45,000. Hydrogen. 1,50,000. Hazards of burning fuels. With increase in population, the fuel consumption has also increased with harmful effects on the environment. Burning fuel produces harmful products. 1. Carbon-containing fuels like wood, coal, petroleum when burnt release unburnt carbon particles. These fine pollutants cause air pollution leading to respiratory diseases and asthma. 2. Solid fuels also leave behind ash which, if not disposed of properly, can cause air and water pollution. 3. Incomplete combustion of fuels produces carbon monoxide gas. Exposure to it can lead to headache and dizziness. It can even cause coma and death. This is why we should not burn coal in a closed room or sleep in a room with a burning coal fire in it. 4. Combustion of fuel releases carbon dioxide in the environment which leads to an increase in temperature on the earth. This causes global warming. Global warming is the rise in temperature of the Earth's atmosphere. It adversely affects climatic patterns. It causes excessive melting of polar glaciers which may lead to rise in the water level in seas and oceans. This in turn may cause floods in coastal areas and submersion of low-lying areas. 5. Burning of coal and fossil fuels releases sulfur dioxide gas and nitrogen oxides. These gases react with water and oxygen producing acids which fall on the earth as acid rain. Acid rain is harmful to plants, soil, buildings, and aquatic life. It is highly corrosive. It is due to acid rain that the marble structure of the Taj Mahal has corroded. 6. Lead compounds are released in exhausts of vehicles which cause severe respiratory problems.